We have a new learning target today. We are starting Module 14, Lesson 1. Our target today is I can use a fraction to show that equal parts of a whole shape have the same area. Now, we've talked about area before, but let's remember, we'll just review a little bit. Area, that is inside a shape. So the example that we use in class to distinguish the difference between area and perimeter is that perimeter is the outside of your swimming pool when you're walking around it, and the area is inside your pool. How much you can fit inside, so how much water would be in your pool. So we're going to be using fractions to show equal parts of a whole that have the same area, the same amount within the shape. So let's look at this first part. This is going to be our Spark Your Learning. My hamsters' names are Alvin, Betty, Coco, and Doug. I put up a wall to divide my hamster's playground into left and right halves. Here's where I divided it, this half right here. Then I put screens up to divide each of these halves into another halves. Now each hamster has a separate play area. Notice I said I put a wall up to divide the left and the right into halves. This and this are both a half. Equally split, so these are going to be the same size, meaning their area is going to be the same as well. Then I took my halves and I split them in half again. So this, a half, another half, and same with these two. So everything got split in half equally. So now I'm going to think to myself, it says, which hamsters will get the largest play space? But I have to remember that this whole play area, I split it in half. So these right now, these two squares that I made they both have the same area. They have the same amount of space because I split them equally in half. So now let's just take this one for example. This one was also split in half equally, which means Alvin and Betty have the same amount of space because it was split evenly. Then let's look at Coco and Doug. Again, I split this half in half again evenly, which means Coco and Doug have the same amount of space. So if I split it in half once, I have a half and a half, but then I know I also split it again in half. So what I'm thinking is because I keep splitting in half, all four of my parts are going to be equal. So our whole playground, how many equal pieces do we have in this playground? We have 1, 2, 3, 4. So the way I'm seeing it is I have 1/4 of a space, 2/4 of a space, 3/4 of a space, and 4/4 of a space. Each play space is split into fourths, meaning each section has the same area. 1, 2, 3, 4 fourths gives me 1 whole, and this is 1 whole playground split into 4 equal sections. So which hamster gets the largest play space? Well, none of them. They have an equal amount of play space. The area that each hamster has to play is the same. So, I wanted to be fair with my hamster, so every hamster got the same amount of space. Now, we're going to look at some circles. Edgar draws lines to divide circles A and B. Both circles are the same size. So both circles, same shape, same size, but they're split differently. First, I'm asked, are the parts of circle A equal or unequal? So say I took this circle and I cut right along my lines. Are these 4 shapes going to fit evenly on top of each other? To me, they look pretty even, right? So I would say equal. Because if I were to cut those shapes out, I could put them on top of each other and it would all be the same size. I also want to think of it as looking at all 4 of these, are they taking up the same amount of space? Do you think they have the same area? Well, they're the same size, they're the same shape, so it would make sense that they'd have the same area too. So now let's look at circle B. Are the parts of circle B equal or unequal? Well, if I cut along each of these lines, are they going to fit on top of each other equally? Or are there going to be some smaller pieces and some bigger pieces? So I would say circle B is unequal. And to show just a visual of that, say I was asked, well, do they have the same area? Well, if I shade in that part of circle B, and then I shade in, say, this middle section, which section, are they the same? No. So do you think they have the same area, or are they equal? No. Now let's look down here. Hopefully you guys can see all of these colors. So right here I have a green, a red, an orange, and a blue. Now here's where we get into thinking about the area. Now remember, the area is the amount of space that's being taken up. So easy with this part is we can just count the amount of squares we have in each shape. That's how we can find our area, because it's the inside. So are the 4 parts of the rectangle equal in area? Well, let's look at it. I have 4 different sections, because you can see that I have the 4 different colors. So let's look at this green part. They want to know if they're equal in area. And how do I know to figure out the area? I know I have to count my squares. So 1, 2, 3, 4, 5, 6. So I'm just going to make a little note that green, its area is 6. Let's look at red. 1, 2, 3, 4, 5, 6. So red also has an area of 6. Now let's look at orange. 1, 2, 3, 4, 5, 6. Again, orange has an area of 6. It's looking like they're all going to be the same, but let's just double check and count the blue too. 1, 2, 3, 4, 5, 6. So do all of the parts of this rectangle, all 4 colors, do they have an equal area? I would say yes, because like I just found over here with counting them, each part has an area of 6. One thing I want you to notice is, even though each of these parts has an area of 6, so their area is equal, notice that they're not all the same shape. I have a rectangle right here. I have an even longer rectangle right here. And then these two, the orange and the blue, kind of look like a P. So none of our shapes are really the same, but it's pretty neat that they all have that same area. Now they want to know, what fraction of the rectangle is shaded blue? Well, here's my whole rectangle. It's split into 4 sections. 1, 2, 3, 4. So what fraction of this rectangle is blue? I know it's split into 4s, and the blue's only taking up 1 of the sections. So 1/4. 1/4 of this rectangle is blue. That's where this down here, this is just a little bit of a review, or like an anchor chart of what we have in the classroom. Equal areas are the same size. We saw that up here. They're the same size. They have 1, 2, 3, 4, 5, 6. Each one has an area of 6. But they're not always the same shape. So you have to remember that maybe they have the same area and they're the same size, but they're not always the same shape. Down here, I have 2 equal areas. One is a circle split in half. There's halves. Half is blue, half is orange. Then I have a rectangle. Again, it's split into 2 equal areas. Half of it's blue, half of it's orange. An area of 3. Do we see that? Then over here, 3 equal areas. I have 1, 2, 3. A third of it's green, a third of it's blue, a third of it's red. Down here, I have a square. It's split into 1/3 of it's green, 1/3 of it's blue, and 1/3 of it is red. Split in to 3 equal areas, but they're different shapes. Still the same size, because the area that they're taking up is still the same amount, but they're different shapes. So you guys are going to be going on to your HMH Math. You are going to be doing Module 14, Lesson 1. If you need any extra help, remember to come back to this video. And if any of these are really going to help you to kind of grasp that concept, mainly pay attention to right here, because this is where we show that even though it's not the same shape, the area is still the same size. Each of them are split in to the same size. So good luck on your assignments, and I hope you guys have a great day.